now come back to the problem solving series we are now on question 6. This problem is going to test our ability to combine multiple differentiation techniques, including logarithmic differentiation, which is a powerful tool for finding compacted products and values. So let's get started. First of all, what was this question asking for question? The first question is function x squared plus b all back to the power of x. We know this is square and plus because the power itself is not as the differential as the x. So when both of these let's start From our recall, from our memory, we know that the derivative with respect to x of a function g of x is the same thing as g prime of x is equals to the differential function g of x. What does this mean? This implies that the derivative with respect to x of our function x function ln, yes, ln of g of x gives us the function g prime of x on g of x. So this tells us that in order to find this derivative, we first need to find our subderivative g prime of x. So identifying ourselves then with this function, we first need to identify our g of x before we can even start. So let g of x be equal to the function x squared plus 1. This implies that v is same thing as the function ln of g of x, and implies that v prime is then the function g prime of x on g of x. G prime of x, which is the derivative with respect to x of our g of x, which is x squared plus 1, is same thing as the derivative with respect to x of the function x squared plus the derivative with respect to x of the function 1. And this is a perfect application of our sum rule, which says that the derivative of a sum is same thing as the sum of their derivatives. Now let's move on to simplifying this. The first time, the derivative with respect to x of x squared gives us 2x to the 2 minus 1, leaving us with 0. All this gives us 2x plus, what's the next term? The derivative with respect to 1, which gives us 0. And why does this give us 0? Because it was well stated in the constant rule that the derivative of any constant gives us 0. So this then implies that g prime of x is the function 2x. Now, substituting this term back here in order to calculate our v prime, we obtain the function v prime equal to g prime of x, 2x, on g of x, x squared plus 1. So now we have our u prime, we have our v prime, we have our u, we have our v. We can then substitute each and every of these terms in our function, in the function u v prime plus v u prime this times. So let's start. Derivative with respect to x of our function uv is u times v prime. What is our u? Our u is the function sine of x times the function v prime 2x on x squared plus 1 plus v. What is our function v? Which is the ln of x squared plus 1, ln of x squared plus 1 times our function u prime. And what is u prime? U prime is the function, yes, the function cos x. So simplifying this, we have 2x sine x on x squared plus 1 plus ln of x squared plus 1 of x. So first of all, what is the derivative of uv? The derivative of uv initially is our function f of x, right? So this derivative is same thing as the derivative of f of x, and f of x is just this term. So what does that tell us? If you can recall very well from our experiment, we were able to simplify all of this to y being equal to the exponent of this, and we said, or recalling from our general laws, that the derivative with respect to x of any function of this form gives us g prime of x e of x. So in order to apply this law, we first need to identify our own g of x. So from our equation, we had the derivative with respect to x of the function e to the f of x, and this was supposed to give us f prime of x e of x. Now this f prime of x was noted to be the product of two different functions, sine x and ln of x squared, and this derivative, or f prime of x, is what we have just found. So in order to calculate the initial derivative for our function y, we then need to substitute the function f prime of x into this initial function. So substituting that, we then have implies the derivative with respect to x of e to the f of x. This implies that f prime of x, which is equal to f prime of x e to the f of x, gives us 2x sine x divided by x squared plus 1 plus ln of x squared plus 1 cos of x, all that times e to our initial function sine of x ln of x squared plus 1. So we can then conclude that therefore the derivative with respect to x of our function y, which is same thing as the derivative with respect to x of our initial function what's the initial function? Yes, of our initial function x squared plus 1 all that to the sine x, which was same thing as the derivative with respect to x of the function to the e to the sine of x ln of x squared plus 1. This simplifies to the function 2x sine x divided by x squared plus 1 plus ln of x squared plus 1 cos x times e to the sine of x ln of x squared plus 1. We then enclose our differential. So this is a classic example of how logarithmic differentiation saves us from messy calculations. We combine logs, chain rule, and even we could combine implicit differentiation, but we have not yet covered that, so we left it out and simplified using logarithmic laws and applications before applying our chain rules and product rules in order to simplify and solve the problem. So in the next question, we'll try solving even more layered and much more complex questions. Thank you and see you in the next video. Bye.